All right, welcome back everybody to another video. Today we're starting our new unit with relationships between two variables. And we've got two vocabulary words, trying to make it as basic as possible. So our first one is our independent variable. This, in a nutshell, is the constant. This will never change, and it's not affected by any other quantity or value. The dependent variable, this is kind of like your output that changes in response to what we input, independent variables. So it's something that we change the input versus the output. And we've seen these before, probably in previous units, where you would have some sort of chart, and you would have your X column and Y. So if you're doing some sort of graphing, you've done this. If you've done converting rates and ratios, you've done this sort of thing. So maybe flip back to some of your earlier units that you've covered in your school this year, and maybe that jogs your memory a little bit. But before we get into it, couple of examples that we have, they have two variables, right? So what we want to make sure is that if they give us a value for the variable, we have to plug that into where that variable is. If we don't have a value for a particular variable, we just leave it alone, and we solve the equation. So my first example that we have here is Sean earns $5 per hour for babysitting. The total amount he earns is X is equal to 5 times the hours H he works. So with these, we have a couple things that we need to remind. We've got $5, and then we can circle $5 and then per hour for babysitting. And then the total amount he earns is X. We don't know. X is equal to 5 times the hours, right? It's a long equation, but what we want to do, X is equal to 5 hours times H. So our independent variable, this is the value that never changes, and that's how much Sean makes in an hour. So it doesn't matter how many hours he babysits, his rate is $5 an hour. So that is our independent variable. Our dependent variable are his hours, right? So if he worked, let's say H is equal to 10. He worked a very long shift, right? We would end this with 5 times 10, and we would have X equal 50. So in 10 hours, Sean would make $50. So that's kind of what we're working with here. So I have a couple example problems that we'll go through, and if you want to pause to try it yourself, you are more than welcome to. So use the equation R equal to Z plus 10 to find the value of R when Z is equal to 4. So we take that and we plug it in. So we end up with R is equal to 4 plus 10, and R is equal to 14. And we are done with this one. Or if we have same thing, R is equal to M minus 2, let the value of R when M is equal to 6, we plug it in. So R is equal to 6 minus 2. R is equal to 4. So when we see two variables, just be extra disciplined to plug in the right value for the correct variable. We're going to skip down to one of these ones that we were talking about. So whenever Jeanette's teacher assigns an essay to write, Jeanette always writes 2 pages more than the minimum. Good job. let M represent the minimum number of pages and W represent the number of pages Jeanette writes. So what we need to do here is we need to solve for W here, and we need to solve for W here. They already gave us two values already done. So we need to input M as 1. So what I'm going to do is draw a line down the middle for however many things that I'm solving for. I want to create that many columns, and that's just how I do things. But just want to stay organized. So W is equal to 1 plus 2. So W is equal to 3. So I will write a 3 there. And then now I need to replace M for 4. So I'm going to do that on the other side. So I have W is equal to 4 plus 2. And W gets me 6. And I input that there. So with these ones, be very careful to input the correct sides. Remember, X is your input, the Y column is your output. You put in, and then the right column are your dependent variables. It all depends on what we input. Let's do another one of these. So farmer has 6 employees who work all year round, and he hires some temporary employees. At harvest time, let B represent the number of temporary employees, and C represent the total number of employees. All right, so we have B is equal to 1, so I'm going to go C is equal to 1 plus 6, because I'm working within this equation. So C is equal to 7, and then I'll do the other one in green on the other side. So I plug in 4 where B is, so C is equal to 4. Oh, sorry, I messed up. Not 4, 3. 3 plus 6. See, I could have solved for it already and had a different value, and I would have 9. So making sure that my X column and my Y column, I'm plugging in the correct numbers. And then we'll do one of these ones. So a small publishing house is taking pre-orders for a novel to be released next month. The number of copies of the novel they will print depends on the number of pre-orders they receive. So which of the variables is independent, which is dependent? Well, they kind of give us the clue right here. The number of copies of the novel they print depends on the number of pre-orders. So if pre-orders are up, the copies are going to go up. If the pre-orders are low, they're going to be lower copies. So our independent variable is our P, the number of pre-orders, right? So we would select that option, and our the number of copies that we get is dependent on the number of pre-orders that we have. And that is all I have for today on relationships between two variables. See you in the next video.